Good morning, Cardinals. So for this problem here, we have a large equilateral triangle, a circle, and a small equilateral triangle, and our goal is to prove the large triangle is 4 times larger than the small triangle. And all we're given is that the radius from the center to the side of this circle is simply r. So we're not given very much information at all. But we can still prove this. We're going to be proving this using the 30, 60, 90 triangle, basically over and over and over again. So we have a triangle that is 30 degrees, 60 degrees, 90 degrees. We know that if the small side of the triangle is x, the hypotenuse must be double that amount, and the long side must be x multiplied by the square root of 3. To get some of these 30, 60, 90s, because I don't have any yet, I need to draw some bisecting lines. I'm going to draw a line that bisects from here down. I'm actually going to do this in black. From the top down here. So cut this first one in half. From this corner over as well. And then finally from this corner over to here. I should get a nice little pattern here. Okay, so, and the reason I'm doing that is once again to create a bunch of 30, 60, 90 triangles. I know that I have these triangles here because the outside triangle is a big equilateral, which means each one of these angles here is going to be 60, which means every time I've bisected it, these smaller angles must be 30, which is perfect. That's exactly what I'm looking for. I'm going to start off with this triangle right here, right there. That triangle right here. I know this is a 90-degree angle here because it is a perpendicular bisector. Up here, I'm sorry, down here, I know this is going to be 30 degrees because it's a 60 degrees that's been cut in half, which means this must be 60. So I have my 30, 60, and 90 triangle. The first thing I'm going to be looking for, first of all, I know that this side of my triangle, my small side, because it is from the center of the circle to the outside of the circle, is r. Knowing that, that tells me both this side over here, this long side, is r square root of 3, and that this hypotenuse here is also going to be x multiplied by the square root of 3. I'm sorry. 2 times x, or not x, oh my gosh, 2 times r. So 2 multiplied by r for that situation there. Cool, so that's already a good little chunk of information that I can use. Again, I need to kind of get the entire triangle here. So if I know the base of this right here is r square root of 3, I also know, because it's bisected, that this side is also r square root of 3. Let's see here. So that's a couple pieces of information for me. So I have one side of my equilateral triangle, which is wonderful. In fact, that's all the information that I need for this. It's a triangle, which means if I want to... Wait a second. No, it's not. I'm going crazy. Sorry, we still need the height. We have to find the height of this thing. So I need to find this line right here. Or really this line right here. Knowing this right here, I have the base of my triangle, which is going to be 2. Radius, square root of 3, because I have 2 of those. That's the base. The height of this is going to be this radius here, plus, so this is the base of my triangle multiplied by the height of my triangle, and I'm going to be using this height here. So my height is going to be my radius and this section here, which we've already found that, which is right here, which is 2r. So r plus 2r. So in other words, this length here is the same as this length over here. So this is 2r. So I have r plus 2r gives me my height, r2r. Base times height, and then I need to divide this by 2 when I'm finished. So r plus 2r gives me 3r. 3r. And now I'm multiplying all this stuff together. So I have 2 times r times the square root of 3 times r, which is kind of nice because all of this stuff kind of gets smushed together. So I have 2, I can do the 2 times the 3, which gives me 6. I have r times this r, which is going to give me r squared, and then finally times the square root of 3. So that is not the actual area of my triangle, but that is the entire area of the square if I was to map a square up and around this triangle. So the final thing I have to do is multiply this by 1/2, which is pretty simple. I can multiply the 6 by the 1/2, which just brings this back down to 3. So the area of my large triangle, is 3 times r squared multiplied by the square root of 3. So there's the area of the large triangle. But again, I need to prove my large triangle is 4 times larger than the small triangle. So I also have to find the small triangle. Cool? I'm going to go through and erase basically all of this stuff so I can redo this process, but with my small equilateral triangle. So once again, erase all this. Woo. Okay, now we're going to find the small triangle. Once again, we are still using the same 30, 60, 90 law to kind of get me through this. And once again, I need to be able to find my height and a base. So I need to figure out both of those. So let's see here. First of all, if I was to just draw out one of these little right triangles here. Right here. So again, this is a right triangle. I know this side was 60 degrees, which means when it's cut in half, that's 30 degrees, and that must be 60 degrees by default. A 90, a 30, the only remaining degree can be 60. So here's my 30, 60, 90 triangle. This time I know my hypotenuse is r. Once again, we're looking at the center of the circle to the side, so that side here is r. That tells me that the small side is going to be half of r, and that the long side down here is going to be half of r times the square root of 3. Again, good information for me. So the base right here of my triangle, again, I'm going to need the base of my small triangle to multiply by the height of my small triangle. Base of my small triangle is going to be 2 of these segments. Both of these are r over 2 times the square root of 3. So once again, I'm adding those two up, or in other words, I have 2 multiplied by everything in there. So I have 2 multiplied by r over 2 times the square root of 3, which is actually pretty nice once again because 2 multiplied by this cancels this out. So this 2 being multiplied by this cancels this and leaves me with a base of just radius multiplied by the square root of 3. Multiplied by, and now I've got to find my height. My height, I need to go straight across from this thing. I know that this distance from here to here is r, so I know that part of my height is going to be r, the radius, plus, and now I got to find this little bit here, which we already found right here. It is r divided by 2, r over 2. And there we go. Cool? The problem with this is beforehand these were being multiplied together, or I'm sorry, let me see, actually, how do I want to do this? Yeah, you know what? I think I'm just going to use distributive property for this. So pushing these two together, I also know that I'm going to be, So I've got r square root of 3 multiplied by everything on the inside of this, which is r plus r over 2. R square root of 3 multiplied by this is going to give me r squared times the square root of 3. So that's the first one done. And then r square root of 3 multiplied by this value over here is going to be r squared times the square root of 3 over 2. So now I have these two values here. Is this how I want to do this? Hold on. You know what? Actually, I think I'm going to combine these two. I'm going to rewind. I'm going to change this up here. So r plus r over this, I'm going to make this r over 1. To add these two fractions together, I need to multiply the base and the denominator by the same number, so 2. So I have 2r plus r over 2. That means I'm going to have r times the square root of 3 multiplied by 3r over 2. Cool? And all of this is because this is just the regular triangle. I still need to multiply this by 1/2 to get the area of my triangle. So I have, let's go kind of, this is over 1. So I'm just going to go all the way across for my numerators. This is going to be equal to, where's my time at? Okay, still good. R square root of 3. I'm going to change the colors for this. So that's my r square root of 3. Then I have 3r. So it's multiplied by 3r. And then finally, I have multiplied by 1, so that doesn't change anything there. Then for my denominator, I have 1 times 2 times 2, which is all over 4. If I was to simplify this out, I have r times the square root of 3 times r. I can rearrange this. So I'm going to put this as 3, 2 r's. So r times r is r squared. Gets rid of these two. Times the square root of 3. And this is all still over 4. So now I'm just going to copy this same thing. R square root of 3, r squared, or 3 times r squared multiplied by the square root of 3 over 4. And that is the area of small triangle. That's the area of my small triangle. And once again, back to my original problem at the very beginning, prove the large triangle is 4 times larger than the small triangle. If this is my area of the large triangle, 3 times r squared times the square root of 3, and the area of my small triangle is 3 times r squared times the square root of 3, but then divided by 4, that means that this value must be 4 times larger than this value. Notice the numerator is the exact same as this guy over here, which means that these two values are the same, okay? In fact, just to kind of really highlight that, really show that real quick, got a few more minutes that I can use on this. Boop. Area of large triangle is 3r squared square root of 3. And then this part over here is 3r squared square root of 3. So the small triangle is the exact same thing, but divided by 4, which means that this is 4 times larger than that. And there you go. So once again, this guy over here was the key to solving our entire problem. There are multiple ways you can go about solving it, but this is the way that I like to do it. Okay? Please let me know if you have any questions. If you do need additional help, please come to my office hours Monday, Wednesday, and Friday at 10 a.m. Goodbye.